Plan and implement security for virtual networks. This module is designed to provide administrators with the knowledge and skills needed to plan and implement robust security measures for Azure Virtual Networks, ensuring the confidentiality, integrity, and availability of network resources. Learning objectives. Implement security measures for Azure Virtual Networks to safeguard data and resources. Utilize NSGs and ASGs for network traffic security, and manage UDRs for optimal traffic routing. Establish secure network connectivity through virtual network peering, VPN gateways, and virtual WAN. Enhance network security with VPN configurations, express route encryption, PAS firewall settings, and network watcher monitoring. Prerequisites. None. This module is part of these learning paths. Introduction. Completed 100 XP. 3 minutes. This module is designed to provide administrators with the knowledge and skills needed to plan and implement robust security measures for Azure Virtual Networks, ensuring the confidentiality, integrity, and availability of network resources. Scenario. Imagine you are an Azure Network Security Specialist responsible for protecting the virtual networks in your organization's cloud environment. Your organization relies on Azure services and needs a comprehensive understanding of network security, from network security groups, NSGs, to encryption over express route. Learning objectives. By the end of this module, participants will be able to plan and implement security measures for virtual networks in Azure to protect data and resources. Effectively use network security groups, NSGs, and application security groups, ASGs, to secure network traffic. Create and manage user-defined routes, UDRs, to optimize network traffic routing. Establish virtual network peering or VPN gateways for secure network connectivity. Plan and implement virtual WAN, including secured virtual hubs, for optimized network management. Secure VPN connectivity, including point-to-site and site-to-site configurations, for remote access and branch connectivity. Implement encryption over express route to ensure data privacy and integrity. Configure firewall settings on Platform as a Service, PaaS, resources to control inbound and outbound traffic. Monitor network security effectively using Network Watcher, including NSG flow logging for threat detection and analysis. Goals. The module aims to equip participants with the knowledge and expertise necessary to design, implement, and maintain a highly secure virtual network environment in Azure. Participants will be able to protect sensitive data, applications, and resources from potential threats and vulnerabilities while maintaining network integrity and availability. Next unit, plan and implement network security groups, NSGs, and application security groups, ASGs. Continue. Need help? See our trouble. Plan and implement network security groups, NSGs, and application security groups, ASGs. Completed 100 XP. 7 minutes. You can use an Azure Network Security Group to filter network traffic between Azure resources in an Azure Virtual Network. A network security group contains security rules that allow or deny inbound network traffic to, or outbound network traffic from, several types of Azure resources. For each rule, you can specify source and destination, port, and protocol. Network security groups, NSGs. Security rules. A network security group contains as many rules as desired, within Azure subscription limits. Each rule specifies the following properties. Expand table. Property explanation. Name a unique name within the network security group. The name can be up to 80 characters long. It must begin with a word character, and it must end with a word character or with underscore. The name may contain word characters or dot, comma underscore. Priority a number between 100 and 4096. Rules are processed in priority order, with lower numbers processed before higher numbers, because lower numbers have higher priority. Once traffic matches a rule, processing stops. As a result, any rules that exist with lower priorities, higher numbers, that have the same attributes as rules with higher priorities aren't processed. Azure default security rules are given the highest number with the lowest priority to ensure that custom rules are always processed first. Source or destination. Any, or an individual IP address, classless interdomain routing, CIDR, block, 10.0.0.024, for example, service tag, or application security group. If you specify an address for an Azure resource, specify the private IP address assigned to the resource. Network security groups are processed after Azure translates a public IP address to a private IP address for inbound traffic, and before Azure translates a private IP address to a public IP address for outbound traffic. Fewer security rules are needed when you specify a range, a service tag, or application security group. The ability to specify multiple individual IP addresses and ranges. You can't specify multiple service tags or application groups. In a rule is referred to as augmented security rules. Augmented security rules can only be created in network security groups created through the Resource Manager deployment model. You can't specify multiple IP addresses and IP address ranges in network security groups created through the classic deployment model. Protocol TCP, UDP, ICMP, ESP, AA, or any. The ESP and AA protocols aren't currently available via the Azure portal but can be used via Azure Resource Manager templates. Direction: whether the rule applies to inbound or outbound traffic. Port range: you can specify an individual or range of ports. For example, you could specify 80 Oregon 10000-10005. Specifying ranges enables you to create fewer security rules. Augmented security rules can only be created in network security groups created through the Resource Manager deployment model. You can't specify multiple ports or port ranges in the same security rule in network security groups created through the classic deployment model. Action: allow or deny. Security rules are evaluated and applied based on the 5-tuple, 1. Source, 2. Source port, 3. Destination, 4. Destination port, and 5. Protocol, information. You can't create two security rules with the same priority and direction. A flow record is created for existing connections. Communication is allowed or denied based on the connection state of the flow record. The flow record allows a network security group to be stateful. If you specify an outbound security rule to any address over port 80, for example, it's not necessary to specify an inbound security rule for the response to the outbound traffic. You only need to specify an inbound security rule if communication is initiated externally. The opposite is also true. If inbound traffic is allowed over a port, it's not necessary to specify an outbound security rule to respond to traffic over the port. Existing connections may not be interrupted when you remove a security rule that allowed the connection. Modifying network security group rules will only affect new connections. When a new rule is created or an existing rule is updated in a network security group, it will only apply to new connections. Existing connections are not re-evaluated with the new rules. How network security groups filter network traffic. You can deploy resources from several Azure services into an Azure virtual network. You can associate 0 or 1 network security group to each virtual network subnet and network interface in a virtual machine. The same network security group can be associated to as many subnets and network interfaces as you choose. The following picture illustrates different scenarios for how network security groups might be deployed to allow network traffic to and from the Internet over TCP port 80. Reference the image, along with the following text, to understand how Azure processes inbound and outbound rules for network security groups. Inbound traffic. For inbound traffic, Azure processes the rules in a network security group associated to a subnet first, if there's one, and then the rules in a network security group associated to the network interface, if there's one. This process includes intra-subnet traffic as well. VM1, the security rules in NSG1 are processed, since it's associated to subnet 1 and VM1 is in subnet 1. Unless you've created a rule that allows port 80 inbound, the deny all inbound default security rule denies the traffic. The traffic doesn't get evaluated by NSG2 because it's associated with the network interface. If NSG1 allows port 80 in its security rule, NSG2 processes the traffic. To allow port 80 to the virtual machine, both NSG1 and NSG2 must have a rule that allows port 80 from the Internet. VM2, the rules in NSG1 are processed because VM2 is also in subnet 1. Since VM2 doesn't have a network security group associated to its network interface, it receives all traffic allowed through NSG1 or is denied all traffic denied by NSG1. Traffic is either allowed or denied to all resources in the same subnet when a network security group is associated to a subnet. VM3, since there's no network security group associated to subnet 2, traffic is allowed into the subnet and processed by NSG2, because NSG2 is associated to the network interface attached to VM3. VM4, traffic is allowed to VM4, because a network security group isn't associated to subnet 3, or the network interface in the virtual machine. All network traffic is allowed through a subnet and network interface if they don't have a network security group associated to them. Outbound traffic. For outbound traffic, Azure processes the rules in a network security group associated to a network interface first, if there's one, and then the rules in a network security group associated to the subnet, if there's one. This process includes intra-subnet traffic as well. VM1, the security rules in NSG2 are processed. The Allow Internet Outbound default security rule in both NSG1 and NSG2 allows the traffic unless you create a security rule that denies port 80 outbound to the Internet. If NSG2 denies port 80 in its security rule, it denies the traffic, and NSG1 never evaluates it. To deny port 80 from the virtual machine, either, or both of the network security groups must have a rule that denies port 80 to the Internet. VM2, all traffic is sent through the network interface to the subnet, since the network interface attached to VM2 doesn't have a network security group associated to it. The rules in NSG1 are processed. VM3, if NSG2 denies port 80 in its security rule, it denies the traffic. If NSG2 doesn't deny port 80, the Allow Internet Outbound default security rule in NSG2 allows the traffic because there's no network security group associated with subnet 2. VM4, all network traffic is allowed from VM4, because a network security group isn't associated to the network interface attached to the virtual machine, or to subnet 3. Intra-subnet traffic. It's important to note that security rules in an NSG associated to a subnet can affect connectivity between VMs within it. By default, virtual machines in the same subnet can communicate based on a default NSG rule allowing intra-subnet traffic. If you add a rule to NSG1 that denies all inbound and outbound traffic, VM1 and VM2 won't be able to communicate with each other. You can easily view the aggregate rules applied to a network interface by viewing the effective security rules for a network interface. You can also use the IP Flow Verify capability in Azure Network Watcher to determine whether communication is allowed to or from a network interface. You can use IP Flow Verify to determine whether a communication is allowed or denied. Additionally, use IP Flow Verify to surface the identity of the network security rule responsible for allowing or denying the traffic. Network security groups are associated to subnets or to virtual machines and cloud services deployed in the classic deployment model, and to subnets or network interfaces in the Resource Manager deployment model. Unless you have a specific reason to, we recommend that you associate a network security group to a subnet, or a network interface, but not both. Since rules in a network security group associated to a subnet can conflict with rules in a network security group associated to a network interface, you can have unexpected communication problems that require troubleshooting. Application Security Groups, ASGs. Application Security Groups enable you to configure network security as a natural extension of an application structure, allowing you to group virtual machines and define network security policies based on those groups. You can reuse your security policy at scale without manual maintenance of explicit IP addresses. The platform handles the complexity of explicit IP addresses and multiple rule sets, allowing you to focus on your business logic. To better understand application security groups, consider the following example. In the previous picture, NIC1 and NIC2 are members of the Ask Web Application Security Group. NIC3 is a member of the Ask Logic Application Security Group. NIC4 is a member of the Ask DB Application Security Group. Though each network interface, NIC, in this example is a member of only one network security group, a network interface can be a member of multiple application security groups, up to the Azure limits. None of the network interfaces have an associated network security group. NSG1 is associated to both subnets and contains the following rules. Allow HTTP inbound internet. This rule is needed to allow traffic from the internet to the web servers. Because inbound traffic from the internet is denied by the Deny All Inbound default security rule, no extra rule is needed for the Ask Logic or Ask DB application security groups. Expand table. Priority source ports destination ports protocol access 100 internet ask web 80 TCP allow. Deny database all. Because the AllowVNet inbound default security rule allows all communication between resources in the same virtual network, this rule is needed to deny traffic from all resources. Expand table. Priority source ports destination ports protocol access 120 ask DB 1433 any deny. Allow database business logic. This rule allows traffic from the Ask Logic application security group to the Ask DB application security group. The priority for this rule is higher than the priority for the denied database all rule. As a result, this rule is processed before the denied database all rule, so traffic from the Ask Logic application security group is allowed, whereas all other traffic is blocked. Expand table. Priority source ports destination ports protocol access 110 Ask Logic Ask DB 1433 TCP allow. Network interfaces that are members of the application security group apply the rules that specify it as the source or destination. The rules don't affect other network interfaces. If the network interface isn't a member of an application security group, the rule isn't applied to the network interface, even though the network security group is associated to the subnet. Application security groups have the following constraints. There are limits to the number of application security groups you can have in a subscription, and other limits related to application security groups. All network interfaces assigned to an application security group have to exist in the same virtual network that the first network interface assigned to the application security group is in. For example, if the first network interface assigned to an application security group named AskWeb is in the virtual network named VNet1, then all subsequent network interfaces assigned to AskWeb must exist in VNet1. You can't add network interfaces from different virtual networks to the same application security group. If you specify an application security group as the source and destination in a security rule, the network interfaces in both application security groups must exist in the same virtual network. An example would be if AskLogic had network interfaces from VNet1 and AskDB had network interfaces from VNet2. In this case, it would be impossible to assign AskLogic as the source and AskDB as the destination in a rule. All network interfaces for both the source and destination application security groups need to exist in the same virtual network. To minimize the number of security rules you need, and the need to change the rules, plan out the application security groups you need and create rules using service tags or application security groups, rather than individual IP addresses, or ranges of IP addresses, whenever possible. Next unit, plan and implement user-defined routes, UDRs. Continue. Need help? See our troubleshooting guide or provide specific feedback by Plan and implement user-defined routes, UDRs. Completed 100 XP. 7 minutes. You can create custom, or user-defined, static, routes in Azure to override Azure's default system routes, or to add more routes to a subnet's route table. In Azure, you create a route table, then associate the route table to 0 or more virtual network subnets. Each subnet can have 0 or 1 route table associated to it. To learn about the maximum number of routes you can add to a route table and the maximum number of user-defined route tables you can create per Azure subscription, see Azure Limits. When you create a route table and associate it to a subnet, the table's routes are combined with the subnet's default routes. If there are conflicting route assignments, user-defined routes override the default routes. You can specify the following next hop types when creating a user-defined route. Virtual appliance. A virtual appliance is a virtual machine that typically runs a network application, such as a firewall. To learn about various pre-configured network virtual appliances you can deploy in a virtual network, see the Azure Marketplace. When you create a route with the virtual appliance hop type, you also specify a next hop IP address. The IP address can be the private IP address of a network interface attached to a virtual machine. Any network interface attached to a virtual machine that forwards network traffic to an address other than its own must have the Azure Enable IP forwarding option enabled for it. The setting disables Azure's check of the source and destination for a network interface. Learn more about how to enable IP forwarding for a network interface. Though Enable IP forwarding is an Azure setting, you may also need to enable IP forwarding within the virtual machine's operating system for the appliance to forward traffic between private IP addresses assigned to Azure network interfaces. If the appliance needs to route traffic to a public IP address, it must either proxy the traffic or perform network address translation, NAT, from the source's private IP address to its own private IP address. Azure then performs NAT to a public IP address before sending the traffic to the internet. To determine required settings within the virtual machine, see the documentation for your operating system or network application. The private IP address of an Azure internal load balancer. A load balancer is often used as part of a high availability strategy for network virtual appliances. You can define a route with 0.0.0.00 as the address prefix and a next hop type of virtual appliance. This configuration allows the appliance to inspect the traffic and determine whether to forward or drop the traffic. If you intend to create a user-defined route that contains the 0.0.0.00 address prefix, read 0.0.0.00 address prefix first. Virtual Network Gateway. Specify when you want traffic destined for specific address prefixes routed to a virtual network gateway. The virtual network gateway must be created with type VPN. You can't specify a virtual network gateway created as type ExpressRoute in a user-defined route because with ExpressRoute, you must use BGP for custom routes. You can't specify virtual network gateways if you have VPN and ExpressRoute coexisting connections either. You can define a route that directs traffic destined for the 0.0.0.00 address prefix to a route-based virtual network gateway. On your premises, you might have a device that inspects the traffic and determines whether to forward or drop the traffic. If you intend to create a user-defined route for the 0.0.0.00 address prefix, read 0.0.0.00 address prefix first. Instead of configuring a user-defined route for the 0.0.0.00 address prefix, you can advertise a route with the 0.0.0.00 prefix via BGP, if you've enabled BGP for a VPN virtual network gateway. None. Specify when you want to drop traffic to an address prefix, rather than forwarding the traffic to a destination. If you haven't fully configured a capability, Azure may list none for some of the optional system routes. For example, if you see none listed as the next hop IP address with a next hop type of virtual network gateway or virtual appliance, it may be because the device isn't running, or isn't fully configured. Azure creates system default routes for reserved address prefixes with none as the next hop type. Virtual network. Specify the virtual network option when you want to override the default routing within a virtual network. Internet. Specify the Internet option when you want to explicitly route traffic destined to an address prefix to the Internet, or if you want traffic destined for Azure services with public IP addresses kept within the Azure Backbone network. You can't specify virtual network peering or virtual network service endpoint as the next hop type in user-defined routes. Routes with the virtual network peering or virtual network service endpoint next hop types are only created by Azure when you configure a virtual network peering or a service endpoint. Service tags for user-defined routes. You can now specify a service tag as the address prefix for a user-defined route instead of an explicit IP range. A service tag represents a group of IP address prefixes from a given Azure service. Microsoft manages the address prefixes encompassed by the service tag and automatically updates the service tag as addresses change, thus minimizing the complexity of frequent updates to user-defined routes and reducing the number of routes you need to create. You can currently create 25 or less routes with service tags in each route table. With this release, using service tags in routing scenarios for containers is also supported. Exact match. The system gives preference to the route with the explicit prefix when there's an exact prefix match between a route with an explicit IP prefix and a route with a service tag. When multiple routes with service tags have matching IP prefixes, routes are evaluated in the following order. Regional tags, for example, storage.east.us, appservice.australia.central. Top-level tags, for example, storage, app service. Azure Cloud regional tags, for example, Azure Cloud.Canada Central, Azure Cloud.East Asia. The Azure Cloud tag. To use this feature, specify a service tag name for the address prefix parameter in route table commands. For example, in PowerShell you can create a new route to direct traffic sent to an Azure Storage IP prefix to a virtual appliance by using Azure PowerShell. $param equals at name equals storage route address prefix equals storage next hop type equals virtual appliance next hop IP address equals 10.0.100.4 new Oz route config at param. The same command for CLI is as follows. Azure CLI, Oz network route table route create / resource group my resource group, route table name my route table, name storage route, address. Plan and implement virtual network peering or gateway. Completed 100 XP. 7 minutes. A virtual network is a virtual, isolated portion of the Azure public network. By default, traffic cannot be routed between two virtual networks. However, it's possible to connect virtual networks, either within a single region or across two regions, so that traffic can be routed between them. Virtual network connection types. Virtual network peering. Virtual network peering connects two Azure virtual networks. Once peered, the virtual networks appear as one for connectivity purposes. Traffic between virtual machines and the peered virtual networks is routed through the Microsoft Backbone infrastructure, through private IP addresses only. No public internet is involved. You can also peer virtual networks across Azure regions. Global peering. VPN gateways. A VPN gateway is a specific type of virtual network gateway that is used to send traffic between an Azure virtual network and an on-premises location over the public internet. You can also use a VPN gateway to send traffic between Azure virtual networks. Each virtual network can have at most one VPN gateway. You should enable Azure DDoS protection standard on any perimeter virtual network. Virtual network peering provides a low latency, high bandwidth connection. There is no gateway in the path, so there are no extra hops, ensuring low latency connections. It's useful in scenarios such as cross-region data replication and database failover. Because traffic is private and remains on the Microsoft Backbone, also consider virtual network peering if you have strict data policies and want to avoid sending any traffic over the internet. VPN gateways provide a limited bandwidth connection and are useful in scenarios where you need encryption but can tolerate bandwidth restrictions. In these scenarios, customers are also not as latency sensitive. Gateway transit. Virtual network peering and VPN gateways can also coexist via gateway transit. Gateway transit enables you to use a peered virtual network's gateway for connecting to on-premises, instead of creating a new gateway for connectivity. As you increase your workloads in Azure, you need to scale your networks across regions and virtual networks to keep up with the growth. Gateway Transit allows you to share an express route or VPN gateway with all peered virtual networks and lets you manage the connectivity in one place. Sharing enables cost savings and reduction in management overhead. With Gateway Transit enabled on virtual network peering, you can create a transit virtual network that contains your VPN gateway, network virtual appliance, and other shared services. As your organization grows with new applications or business units and as you spin up new virtual networks, you can connect to your transit virtual network using peering. This prevents adding complexity to your network and reduces management overhead of managing multiple gateways and other appliances. Configuring connections. Virtual network peering and VPN gateways both support the following connection types. Virtual networks in different regions. Virtual networks in different Microsoft Entra tenants. Virtual networks in different Azure subscriptions. Virtual networks that use a mix of Azure deployment models, Resource Manager and Classic. Comparison of virtual network peering and VPN gateway. Expand table. Item virtual network peering VPN gateway limits up to 500 virtual network peerings per virtual network, 1 VPN gateway per virtual network. The maximum number of tunnels per gateway depends on the gateway SKU. Pricing model ingress/egress hourly plus egress encryption software level encryption is recommended. Custom IPsec/IKE policy can be applied to new or existing connections. Bandwidth limitations. No bandwidth limitations. Varies based on SKU. Private? Yes. Routed through Microsoft Backbone and private. No public internet involved. Public IP involved, but routed through Microsoft Backbone if Microsoft Global Network is enabled. Transitive relationship peering connections are non-transitive. Transitive networking can be achieved using NVAs or gateways in the hub virtual network. If virtual networks are connected via VPN gateways and BGP is enabled in the virtual network connections, transitivity works. Initial setup time fast 30 minutes. Typical scenarios: data replication, database failover, and other scenarios needing frequent backups of large data. Encryption specific scenarios that are not latency sensitive and do not need high throughput. Next unit, plan and implement virtual wide area network, including secured virtual hub. Continue. Need help? See our troubleshooting guide or provide Plan and implement virtual wide area network, including secured virtual hub. Completed 100 XP. 7 minutes. A virtual WAN connects to your resources in Azure over an IPsec/IKE, a Cave 1 and a Cave 2, VPN connection. This type of connection requires a VPN device located on premises that has an externally facing public IP address assigned to it. Prerequisites. Verify that you have an Azure subscription. If you don't already have an Azure subscription, you can activate your MSDN subscriber benefits or sign up for a free account. Decide the IP address range that you want to use for your virtual hub private address space. This information is used when configuring your virtual hub. A virtual hub is a virtual network that is created and used by virtual WAN. It's the core of your virtual WAN network in a region. The address space range must conform to certain rules. The address range that you specify for the hub can't overlap with any of the existing virtual networks that you connect to. The address range can't overlap with the on-premises address ranges that you connect to. If you're unfamiliar with the IP address ranges located in your on-premises network configuration, coordinate with someone who can provide those details for you. Azure Portal or Azure PowerShell. You can use either the Azure Portal or Azure PowerShell templates to create a site-to-site connection to Azure Virtual WAN. The Cloud Shell is a free interactive shell that has common Azure tools pre-installed and configured to use with your account. To open Cloud Shell, just select Open Cloud Shell from the upper right corner of a code block. You can also open Cloud Shell on a separate browser tab by going to https://shell.azure.com/PowerShell. Select Copy to copy the blocks of code, paste them into Cloud Shell, and select the Enter key to run them. You can also install and run the Azure PowerShell templates locally on your computer. PowerShell templates are updated frequently. If you haven't installed the latest version, the values specified in the instructions may fail. To find the versions of Azure PowerShell installed on your computer, use the Get Module list available as template. Sign in. If you're using Azure Cloud Shell, you'll automatically be directed to sign into your account after you open Cloud Shell. You don't need to run ConnectOz account. Once signed in, you can still change subscriptions if necessary by using Get Oz subscription and Select Oz subscription. If you're running PowerShell locally, open the PowerShell console with elevated privileges and connect to your Azure account. The ConnectOz account template prompts you for credentials. After you authenticate, it downloads your account settings so that they're available to Azure PowerShell. You can change subscription by using Get Oz subscription and Select Oz subscription. Subscription name of subscription. Create a virtual WAN. Before you can create a virtual WAN, you have to create a resource group to host the virtual WAN or use an existing resource group. Use one of the following examples. This example creates a new resource group named TestRG in the East US location. If you want to use an existing resource group instead, you can modify the $resource group equals getAs resource group name of resource group command, and then complete the steps in this exercise using your own values. Create a resource group, Azure PowerShell, new Oz resource group location East US name TestRG. Create the virtual when using the new Oz virtual WANblet. Azure PowerShell. $virtual when equals new Oz virtual WAN resource group name TestRG name test1 location East US. Create the hub and configure hub settings. A hub is a virtual network that can contain gateways for site-to-site, express route, or point-to-site functionality. Create a virtual hub with new Oz virtual hub. This example creates a default virtual hub named Hub1 with the specified address prefix and a location for the hub. Azure PowerShell. $virtual hub equals new Oz virtual hub virtual WAN $virtual WAN resource group name TestRG name hub1 address prefix 10.1.0.016 location Westus. Create a site-to-site VPN gateway. In this section, you create a site-to-site VPN gateway in the same location as the referenced virtual hub. When you create the VPN gateway, you specify the scale units that you want. It takes about 30 minutes for the gateway to create. If you closed Azure Cloud Shell or your connection timed out, you may need to declare the variable again for $virtual hub. Azure PowerShell. $virtual hub equals getAs virtual hub resource group name TestRG name hub1. Create a site and connections. In this section, you create sites that correspond to your physical locations and the connections. These sites contain your on-premises VPN device endpoints. You can create up to 1,000 sites per virtual hub in a virtual WAN. If you have multiple hubs, you can create 1,000 per each of those hubs. Set the variable for the VPN gateway and for the IP address space that is located on your on-premises site. Traffic destined for this address space is routed to your local site. This is required when BGP isn't enabled for the site. Azure PowerShell. $VPN gateway equals getAs VPN gateway resource. Create links to add information about the physical links at the branch including metadata about the link speed, link provider name, and the public IP address of the on-premises device. Azure PowerShell. $VPN site link 1 equals new Oz VPN site link name test site 1 link 1 IP address 15.25.35.45 link. Create the VPN site, referencing the variables of the VPN site links you just created. If you closed Azure Cloud Shell or your connection timed out, redeclare the virtual WAN variable. Azure PowerShell. $virtual WAN equals getAs virtual WAN resource group name TestRG name test1. Create the VPN site using the new Oz VPN site template. Create the site link connection. The connection is composed of two active tunnels from a branch/site to the scalable gateway. Azure PowerShell. $VPN site link connection 1 equals new Oz VPN site link connection name test link connection 1 VPN site link $VPN. Connect the VPN site to a hub. Connect your VPN site to the hub site-to-site VPN gateway using the new Oz VPN connection template. Before running the command, you may need to redeclare the following variables. Azure PowerShell. $virtual WAN equals getAs virtual WAN resource group name TestRG name test1. $VPN gateway equals getAs VPN. Connect VNet to your hub. The next step is to connect the hub to the VNet. If you created a new resource group for this exercise, you typically won't already have a virtual network, VNet, in your resource group. The steps below help you create a VNet if you don't already have one. You can then create a connection between the hub and your VNet. Create a virtual network. You can use the following example values to create a VNet. Make sure to substitute the values in the examples for the values you used for your environment. Create a VNet. Azure PowerShell. $VNet equals name equals VNet1. Resource group name equals TestRG. Location equals Eastus. Specify subnet settings. Azure PowerShell. $subnet equals name equals subnet. Set the VNet. Azure PowerShell. $virtual network. Set Oz virtual network. Connect a VNet to a hub. Configure VPN device. Next unit, secure VPN connectivity, including point-to-site and site-to-site. Continue. Need help? See our troubleshooting. Secure VPN connectivity, including point-to-site and site-to-site. Completed 100 XP. 7 minutes. It's important to know that there are different configurations available for VPN gateway connections. You need to determine which configuration best fits your needs. In the sections below, You can view design information and topology diagrams about the following VPN gateway connections. Use the diagrams and descriptions to help select the connection topology to match your requirements. The diagrams show the main baseline topologies, but it's possible to build more complex configurations using the diagrams as guidelines. Site-to-site VPN. A site-to-site, S2S, VPN gateway connection is a connection over IPsec/IKE, a Cave1 or a Cave2, VPN tunnel. S2S connections can be used for cross-premises and hybrid configurations. A S2S connection requires a VPN device located on premises that has a public IP address assigned to it. VPN gateway can be configured in active standby mode using one public IP or in active mode using two public IPs. In active standby mode, one IPsec tunnel is active and the other tunnel is in standby. In this setup, traffic flows through the active tunnel, and if some issue happens with this tunnel, the traffic switches over to the standby tunnel. Setting up VPN gateway in active mode is recommended in which both the IPsec tunnels are simultaneously active, with data flowing through both tunnels at the same time. An additional advantage of active mode is that customers experience higher throughputs. You can create more than one VPN connection from your virtual network gateway, typically connecting to multiple on-premises sites. When working with multiple connections, you must use a route-based VPN type, known as a dynamic gateway when working with classic nets. Because each virtual network can only have one VPN gateway, all connections through the gateway share the available bandwidth. This type of connection is sometimes referred to as a multi-site connection. Point-to-site virtual private network. A point-to-site, P2S, VPN gateway connection lets you create a secure connection to your virtual network from an individual client computer. A P2S connection is established by starting it from the client computer. This solution is useful for telecommuters who want to connect to Azure VNets from a remote location, such as from home or a conference. P2S VPN is also a useful solution to use instead of S2S VPN when you have only a few clients that need to connect to VNet. Unlike S2S connections, P2S connections don't require an on-premises public-facing IP address or a VPN device. P2S connections can be used with S2S connections through the same VPN gateway, as long as all the configuration requirements for both connections are compatible. VNet to VNet connections, Internet Protocol Secure/Internet Key Exchange Virtual Private Network Tunnel. Connecting a virtual network to another virtual network, VNet to VNet, is similar to connecting a VNet to an on-premises site location. Both connectivity types use a VPN gateway to provide a secure tunnel using IPsec/IKE. You can even combine VNet to VNet communication with multi-site connection configurations. This lets you establish network topologies that combine cross-premises connectivity with inter-virtual network connectivity. The VNets you connect can be in the same or different regions, in the same or different subscriptions, in the same or different deployment models. Connections between deployment models. Azure currently has two deployment models, Classic and Resource Manager. If you have been using Azure for some time, you probably have Azure VMs and instance roles running in a Classic VNet. Your newer VMs and role instances may be running in a VNet created in Resource Manager. You can create a connection between the VNets to allow the resources in one VNet to communicate directly with resources in another. VNet peering. You may be able to use VNet peering to create your connection, as long as your virtual network meets certain requirements. VNet peering doesn't use a virtual network gateway. Site-to-site and express route coexisting connections. Express route is a direct, private connection from your WAN, not over the public internet, to Microsoft services, including Azure. Site-to-site VPN traffic travels encrypted over the public internet. Being able to configure site-to-site VPN and express route connections for the same virtual network has several advantages. You can configure a site-to-site VPN as a secure failover path for express route, or use site-to-site VPNs to connect to sites that aren't part of your network, but that are connected through express route. Notice that this configuration requires two virtual network gateways for the same virtual network, one using the gateway type VPN, and the other using the gateway type express route. Next unit, Azure Express Route. Continue. Need help? See our troubleshooting guide. Azure Express Route. Completed 100 XP. 3 minutes. Express Route lets you extend your on-premises networks into the Microsoft Cloud over a private connection with the help of a connectivity provider. With Express Route, you can establish connections to Microsoft Cloud services, such as Microsoft Azure and Microsoft 365. Connectivity can be from an any-to-any, IPVPN, network, a point-to-point Ethernet network, or a virtual cross-connection through a connectivity provider at a colocation facility. Express route connections offer more reliability, faster speeds, consistent latencies, and higher security than typical connections over the internet, because they don't go over the public internet. Key benefits: Layer 3 connectivity between your on-premises network and the Microsoft Cloud through a connectivity provider. Connectivity can be from an any-to-any, IPFN, network, a point-to-point Ethernet connection, or through a virtual cross-connection via an Ethernet exchange. Connectivity to Microsoft Cloud services across all regions in the geopolitical region. Global connectivity to Microsoft services across all regions with the ExpressRoute Premium add-on. Dynamic routing between your network and Microsoft via Border Gateway Protocol, BGP. Built-in redundancy in every peering location for higher reliability. Connection Uptime Service Level Agreement, SLA. Quality of service, COS, support for Skype for Business. Features: Layer 3 connectivity. Microsoft uses BGP, an industry-standard dynamic routing protocol, to exchange routes between your on-premises network, your instances in Azure, and Microsoft public addresses. We establish multiple BGP sessions with your network for different traffic profiles. Redundancy. Each ExpressRoute circuit consists of 2 connections to 2 Microsoft Enterprise Edge routers, MZEs, at an ExpressRoute location from the connectivity provider or your network edge. Microsoft requires dual BGP connections from the connectivity provider or your network edge, one to each MZE. You might choose not to deploy redundant devices/Ethernet circuits at your end. However, connectivity providers use redundant devices to ensure that your connections are handed off to Microsoft in a redundant manner. Connectivity to Microsoft Cloud services. ExpressRoute connections enable access to the following services: Microsoft Azure services, Microsoft 365 services, connectivity to all regions within a geopolitical region. You can connect to Microsoft from one of our peering locations and access regions within the same geopolitical region. For example, if you connect to Microsoft in Amsterdam through ExpressRoute, you have access to all of Microsoft Cloud services hosted in North and West Europe. Global connectivity with ExpressRoute Premium. You can enable ExpressRoute Premium to extend connectivity across geopolitical boundaries. If you connect to Microsoft in Amsterdam through ExpressRoute, you have access to all of Microsoft Cloud services hosted in every region across the globe. For example, you have access to services deployed in West US or Australian East the same way you access North and West Europe regions. National clouds are excluded. Local connectivity with ExpressRoute Local. You can transfer data cost effectively by enabling the local stock keeping units, SKU. With local SKU, you can bring your data to an ExpressRoute location near the Azure region you want. With local, data transfer is included in the ExpressRoute port charge. Across on-premises connectivity with ExpressRoute Global Reach. By enabling ExpressRoute Global Reach, you can exchange data across your on-premises sites through your ExpressRoute circuits. For instance, suppose you have 2 private data centers, one in California and one in Texas, each connected to an ExpressRoute circuit in their respective regions. You can use ExpressRoute Global Reach to link your data centers with these circuits, and your cross-data center traffic uses the Microsoft network. Rich connectivity partner ecosystem. ExpressRoute has a constantly growing ecosystem of connectivity providers and systems integrator partners. Connectivity to national clouds. Microsoft operates isolated cloud environments for special geopolitical regions and customer segments. ExpressRoute Direct. ExpressRoute Direct provides customers the opportunity to connect directly into Microsoft's global network at peering locations strategically distributed across the world. ExpressRoute Direct provides dual 100 Gbps connectivity, which supports active/active connectivity at scale. Key features that ExpressRoute Direct provides include, but aren't limited to, massive data ingestion into services like Azure Storage and Azure Cosmos DB, physical isolation for industries that are regulated and require dedicated and isolated connectivity. For example, banks, governments, and retails. Granular control of circuit distribution based on business unit. Bandwidth options. You can purchase ExpressRoute circuits for a wide range of bandwidths. The supported bandwidths are listed as follows. Be sure to check with your connectivity provider to determine the bandwidths they support. 50 megabits per second, Mbps. 100 megabits per second. 200 megabits per second. 500 megabits per second. 1 gigabit per second, Gbps. 2 gigabits per second. 5 gigabits per second. 10 gigabits per second. The built-in redundancy of your circuit is configured using primary and secondary connections, each of the procured bandwidth, to 2 Microsoft Enterprise Edge routers, MZEs. The bandwidth available through your secondary connection can be used for more traffic if necessary. Since the secondary connection is meant for redundancy, it isn't guaranteed and shouldn't be used for extra traffic for a sustained period of time. If you plan to use only your primary connection to transmit traffic, the bandwidth for the connection is fixed, and attempting to oversubscribe it results in increased packet drops. Dynamic scaling of bandwidth. You can increase the ExpressRoute circuit bandwidth without having to tear down your connections. Flexible billing models. You can select a billing model that works best for you. Unlimited data. Billing is based on a monthly fee. All inbound and outbound data transfer is included free of charge. Metered data. Billing is based on a monthly fee. All inbound data transfer is free of charge. Outbound data transfer is charged per gigabyte of data transfer. Data transfer rates vary by region. Express Route Premium add-on. Express Route Premium is an add-on to the Express Route circuit. The Express Route Premium add-on provides the following capabilities. Increased route limits for Azure Public and Azure Private peering from 4,000 routes to 10,000 routes. Global connectivity for services. An Express Route circuit created in any region, excluding national clouds, has access to resources across every other region in the world. For example, a virtual network created in West Europe can be accessed through an Express Route circuit provisioned in Silicon Valley. Increased number of virtual network links per Express Route circuit from 10 to a larger limit, depending on the bandwidth of the circuit. Next unit. Implement encryption over Express Route. Implement encryption over Express Route. Completed 100 XP. 7 minutes. Deploy Azure Virtual WAN to establish an IPsec/IKE VPN connection from your on-premises network to Azure over the private peering of an Azure Express Route circuit. This technique can provide an encrypted transit between the on-premises networks and Azure Virtual Networks over Express Route, without going over the public internet or using public IP addresses. Topology and routing. The diagram shows a network within the on-premises network connected to the Azure Hub VPN gateway over Express Route private peering. The connectivity establishment is straightforward. Establish Express Route connectivity with an Express Route circuit and private peering. Establish the VPN connectivity as described in the example. An important aspect of this configuration is routing between the on-premises networks and Azure over both the Express Route and VPN paths. Traffic from on-premises networks to Azure. For traffic from on-premises networks to Azure, the Azure prefixes, including the virtual hub and all the spoke virtual networks connected to the hub, are advertised via both the Express Route Private Peering BGP and the VPN BGP. This results in two network routes, paths, toward Azure from the on-premises networks, one over the IPsec protected path, one directly over Express Route without IPsec protection. To apply encryption to the communication, you must make sure that for the VPN connected network in the diagram, the Azure routes via on-premises VPN gateway are preferred over the direct Express Route path. Traffic from Azure to on-premises networks. The same requirement applies to the traffic from Azure to on-premises networks. To ensure that the IPsec path is preferred over the direct Express Route path, without IPsec, you have two options. Advertise more specific prefixes on the VPN BGP session for the VPN connected network. You can advertise a larger range that encompasses the VPN connected network over Express Route private peering, then more specific ranges in the VPN BGP session. For example, advertise 10.0.0.016 over Express Route, and 10.0.1.024 over VPN. Advertise disjoint prefixes for VPN and Express Route. If the VPN connected network ranges are disjoint from other Express Route connected networks, you can advertise the prefixes in the VPN and Express Route BGP sessions respectively. For example, advertise 10.0.0.024 over Express Route, and 10.0.1.024 over VPN. In both of these examples, Azure will send traffic to 10.0.1.024 over the VPN connection rather than directly over Express Route without VPN protection. Before you start your configuration, verify that you meet the following criteria. If you already have virtual network that you want to connect to, verify that none of the subnets of your on-premises network overlap with it. Your virtual network doesn't require a gateway subnet and can't have any virtual network gateways. If you don't have a virtual network, you can create one by using the steps in this article. Obtain an IP address range for your hub region. The hub is a virtual network, and the address range that you specify for the hub region can't overlap with an existing virtual network that you connect to. It also can't overlap with the address ranges that you connect to on-premises. If you're unfamiliar with the IP address ranges located in your on-premises network configuration, coordinate with someone who can provide those details for you. If you don't have an Azure subscription, create a free account before you begin. Create a virtual WAN and hub with gateways. The following Azure resources and the corresponding on-premises configurations must be in place before you proceed. An Azure Virtual WAN. A virtual WAN hub with an Express Route and a virtual private network gateway. Create a site for the on-premises network. The site resource is the same as the non-Express Route VPN sites for a virtual WAN. The IP address of the on-premises VPN device can now be either a private IP address, or a public IP address in the on-premises network reachable via the previously created ExpressRoute private peering configuration. Go to your virtual WAN, VPN sites and create a site for your on-premises network. Keep in mind the following settings values. Border Gateway Protocol. Select Enable if your on-premises network uses BGP. Private address space. Enter the IP address space that's located on your on-premises site. Traffic destined for this address space is routed to the on-premises network via the VPN gateway. Select links to add information about the physical links. Keep in mind the following settings information. Provider name, the name of the internet service provider for this site. For an ExpressRoute on-premises network, it's the name of the ExpressRoute service provider. Speed, the speed of the internet service link or ExpressRoute circuit. IP address, the public IP address of the VPN device that resides on your on-premises site. Or, for ExpressRoute on-premises, it's the private IP address of the VPN device via ExpressRoute. If BGP is enabled, it applies to all connections created for this site in Azure. Configuring BGP on a virtual WAN is equivalent to configuring BGP on an Azure VPN gateway. Your on-premises BGP peer address must not be the same as the IP address of your VPN to the device or the virtual network address space of the VPN site. Use a different IP address on the VPN device for your BGP peer IP. It can be an address assigned to the loopback interface on the device. However, it can't be an APIPA 169.254.x.x address. Specify this address in the corresponding VPN site that represents the location. Select Next, Review plus Create to check the setting values and create the VPN site, then create the site. Next, connect the site to the hub. It can take up to 30 minutes to update the gateway. Update the VPN connection setting to use ExpressRoute. After you create the VPN site and connect to the hub, use the following steps to configure the connection to use ExpressRoute private peering. Go to the virtual hub. You can either do this by going to the virtual WAN and selecting the hub to open the hub page, or you can go to the connected virtual hub from the VPN site. Under Connectivity, select VPN, Site to Site. Select the ellipsis, or right-click the VPN site over ExpressRoute, and select Edit VPN connection to this hub. On the Basics page, leave the defaults. On the Link Connection 1 page, configure the following settings. For use Azure Private IP Address, select Yes. The setting configures the Hub VPN gateway to use private IP addresses within the hub address range on the gateway for this connection, instead of the public IP addresses. This ensures that the traffic from the on-premises network traverses the ExpressRoute private peering paths rather than using the public internet for this VPN connection. Click Create to update the settings. After the settings have been created, the Hub VPN gateway will use the private IP addresses on the VPN gateway to establish the IPsec/IKE connections with the on-premises VPN device over ExpressRoute. Get the private IP addresses for the Hub VPN gateway. Download the VPN device configuration to get the private IP addresses of the Hub VPN gateway. You need these addresses to configure the on-premises VPN device. On the page for your hub, select VPN, Site to Site, under Connectivity. At the top of the overview page, select Download VPN config. Azure creates a storage account in the resource group Microsoft Network Location, where location is the location of the WAN. After you apply the configuration to your VPN devices, you can delete this storage account. After the file is created, select the link to download it. Apply the configuration to your VPN device. VPN device configuration file. The device configuration file contains the settings to use when you're configuring your on-premises VPN device. When you view this file, notice the following information. VPN site configuration. This section denotes the device details setup as a site that's connecting to the virtual WAN. It includes the name and public IP address of the branch device. VPN site connections. This section provides information about the following settings. Address space of the virtual hub's virtual network. Example. Address space 10.51.230.024. Address space of the virtual networks that are connected to the hub. Example. Connected subnets 10.51.231.024. IP addresses of the virtual hub's VPN gateway. Because each connection of the VPN gateway is composed of two tunnels in active-active configuration, you'll see both IP addresses listed in this file. In this example, you see instance 0 and instance 1 for each site, and their private IP addresses instead of public IP addresses. Example. Instance 0, 10.51.230.4. Instance 1, 10.51.230.5. Configuration details for the VPN gateway connection, such as BGP and pre-shared key. The pre-shared key is automatically generated for you. You can always edit the connection on the overview page for a custom pre-shared key. Example device configuration file. Configuration version. Last updated time, 2019-10-11 T05:57:35.1803. Configure firewall settings on PAS resources. Completed 100 XP. 7 minutes. Modernizing the Defender for Clouds mindset. With PAS deployments come a shift in your overall approach to security. You shift from needing to control everything yourself to sharing responsibility with Microsoft. Another significant difference between PAS and traditional on-premises deployments is a new view of what defines the primary security perimeter. Historically, the primary on-premises security perimeter was your network, and most on-premises security designs use the network as its primary security pivot. For PAS deployments, you are better served by considering identity to be the primary security perimeter. Adopt a policy of identity as the primary security perimeter. One of the 5 essential characteristics of cloud computing is broad network access, which makes network-centric thinking less relevant. The goal of much of cloud computing is to allow users to access resources regardless of location. For most users, their location is going to be somewhere on the internet. The following figure shows how the security perimeter has evolved from a network perimeter to an identity perimeter. Security becomes less about defending your network and more about defending your data, as well as managing the security of your apps and users. The key difference is that you want to push security closer to what's important to your company. Initially, Azure PAS services, for example, web roles and Azure SQL, provided little or no traditional network perimeter defenses. It was understood that the element's purpose was to be exposed to the internet, web role, and that authentication provides the new perimeter, for example, Blob or Azure SQL. Modern security practices assume that the adversary has breached the network perimeter. Therefore, modern defense practices have moved to identity. Organizations must establish an identity-based security perimeter with strong authentication and authorization hygiene, best practices. Principles and patterns for the network perimeter have been available for decades. In contrast, the industry has relatively less experience with using identity as the primary security perimeter. With that said, we have accumulated enough experience to provide some general recommendations that are proven in the field and apply to almost all PAS services. The following are best practices for managing the identity perimeter. Best practice: secure your keys and credentials to secure your PAS deployment. Detail: losing keys and credentials is a common problem. You can use a centralized solution where keys and secrets can be stored in hardware security modules, HSMs. Azure Key Vault safeguards your keys and secrets by encrypting authentication keys, storage account keys, data encryption keys, PFX, files, and passwords using keys that are protected by HSMs. Best practice: don't put credentials and other secrets in source code or GitHub. Detail: the only thing worse than losing your keys and credentials is having an unauthorized party gain access to them. Attackers can take advantage of bot technologies to find keys and secrets stored in code repositories such as GitHub. Do not put key and secrets in these public code repositories. Best practice: protect your VM management interfaces on hybrid PAS and IaaS services by using a management interface that enables you to remote manage these VMs directly. Detail: remote management protocols such as SSH, RDP, and PowerShell remoting can be used. In general, we recommend that you do not enable direct remote access to VMs from the internet. If possible, use alternate approaches like using virtual private networks in an Azure virtual network. If alternative approaches are not available, ensure that you use complex passphrases and two-factor authentication, such as Microsoft Entra multi-factor authentication. Best practice: use strong authentication and authorization platforms. Detail: use federated identities in Microsoft Entra Idaho instead of custom user stores. When you use federated identities, you take advantage of a platform-based approach and you delegate the management of authorized identities to your partners. A federated identity approach is especially important when employees are terminated and that information needs to be reflected through multiple identity and authorization systems. Use platform-supplied authentication and authorization mechanisms instead of custom code. The reason is that developing custom authentication code can be error-prone. Most of your developers are not security experts and are unlikely to be aware of the subtleties and the latest developments in authentication and authorization. Commercial code, for example, from Microsoft, is often extensively security reviewed. Use two-factor authentication. Two-factor authentication is the current standard for authentication and authorization because it avoids the security weaknesses inherent in username and password types of authentication. Access to both the Azure Management Portal/Remote PowerShell interfaces and customer-facing services should be designed and configured to use Microsoft Entra multi-factor authentication. Use standard authentication protocols, such as OAuth 2 and Kerberos. These protocols have been extensively peer-reviewed and are likely implemented as part of your platform libraries for authentication and authorization. Use threat modeling during application design. The Microsoft Security Development Lifecycle specifies that teams should engage in a process called threat modeling during the design phase. To help facilitate this process, Microsoft has created the SDL Threat Modeling tool. Modeling the application design and enumerating stride threats across all trust boundaries can catch design errors early on. The following table lists the stride threats and gives some example mitigations that use Azure features. These mitigations won't work in every situation. Expand table. Threat security. Develop on Azure App Service. Azure App Service is a PaaS offering that lets you create web and mobile apps for any platform or device and connect to data anywhere, in the cloud or on premises. App Service includes the web and mobile capabilities that were previously delivered separately as Azure Websites and Azure Mobile Services. It also includes new capabilities for automating business processes and hosting cloud APIs. As a single integrated service, App Service brings a rich set of capabilities to web, mobile, and integration scenarios. Following are best practices for using App Service. Best practice: authenticate through Microsoft Entra ID. Detail: App Service provides an OAuth 2.0 service for your identity provider. OAuth 2.0 focuses on client developer simplicity while providing specific authorization flows for web applications, desktop applications, and mobile phones. Microsoft Entra ID uses OAuth 2.0 to enable you to authorize access to mobile and web applications. Best practice: restrict access based on the need to know and least privilege security principles. Detail: restricting access is imperative for organizations that want to enforce security policies for data access. You can use Azure Back to assign permissions to users, groups, and applications at a certain scope. To learn more about granting users access to applications, see Get Started with Access Management. Best practice: protect your keys. Detail: Azure Key Vault helps safeguard cryptographic keys and secrets that cloud applications and services use. With Key Vault, you can encrypt keys and secrets, such as authentication keys, storage account keys, data encryption keys, PFX, files, and passwords, by using keys that are protected by hardware security modules, HSMs. For added assurance, you can import or generate keys in HSMs. See Azure Key Vault to learn more. You can also use Key Vault to manage your TLS certificates with auto-renewal. Best practice: restrict incoming source IP addresses. Detail: App Service Environment has a virtual network integration feature that helps you restrict incoming source IP addresses through network security groups. Virtual networks enable you to place Azure resources in a non-internet, routable network that you control access to. To learn more, see Integrate your app with an Azure virtual network. Best practice: monitor the security state of your app service environments. Detail: use Microsoft Defender for Cloud to monitor your app service environments. When Defender for Cloud identifies potential security vulnerabilities, it creates recommendations that guide you through the process of configuring the needed controls. Azure Cloud Services. Azure Cloud Services is an example of a PaaS. Like Azure App Service, this technology is designed to support applications that are scalable, reliable, and inexpensive to operate. In the same way that App Service is hosted on virtual machines, VMs, so too is Azure Cloud Services. However, you have more control over the VMs. You can install your own software on VMs that use Azure Cloud Services, and you can access them remotely. DDoS protection. Azure DDoS protection, combined with application design best practices, provides enhanced DDoS mitigation features to provide more defense against DDoS attacks. You should enable Azure DDoS protection on any perimeter virtual network. Monitor the performance of your applications. Monitoring is the act of collecting and analyzing data to determine the performance, health, and availability of your application. An effective monitoring strategy helps you understand the detailed operation of the components of your application. It helps you increase your uptime by notifying you of critical issues so that you can resolve them before they become problems. It also helps you detect anomalies that might be security related. Use Azure Application Insights to monitor availability, performance, and usage of your application, whether it's hosted in the cloud or on premises. By using Application Insights, you can quickly identify and diagnose errors in your application without waiting for a user to report them. With the information that you collect, you can make informed choices on your application's maintenance and improvements. Application Insights has extensive tools for interacting with the data that it collects. Application Insights stores its data in a common repository. It can take advantage of shared functionality such as alerts, dashboards, and deep analysis with the Custo query language. Next unit: monitor network security by using Network Watcher, including network Create. Monitor network security by using Network Watcher, including network security groups. Azure Network Watcher provides a suite of tools to monitor, diagnose, view metrics, and enable or disable logs for Azure IaaS, Infrastructure as a Service, resources. Network Watcher enables you to monitor and repair the network health of IaaS products like virtual machines, VM. Network Watcher isn't designed or intended for PaaS monitoring or web analytics.